My name is Toby and I will give you 3 most important tips you can utilize when it comes to setting up a reliable and durable CAN network, and if you want to set up larger CAN networks. So, first things first. Many people think that the setup is quite easy without any additional hurdles. Unfortunately, this is rarely the case. So let's look at our first example. The first common mistake happens when wiring the different nodes within your CAN network. Here's my first tip. It's very important to have a clean line topology. It means that the drop lines should be kept as short as possible to avoid signal loopbacks that could degrade signal quality and system reliability. And when it comes to cabling, we recommend you use a shielded CAN cable with CAN high, CAN low and CAN ground. Use a twisted pair for CAN high and CAN low with 120 ohm impedance. This minimizes external electromagnetic influences. And it's also important to ground the CAN shield only on one side to avoid ground loops. Here's my second tip for you. You must use CAN termination resistors. The termination at each end absorbs the CAN signal energy, ensuring that it does not get reflected from the cable ends. That means the terminating resistor is a signal quality component. But which resistors do you need to use? According to the line impedance, the termination resistors must be 120 ohm. So at both sides of the bus, a 120 ohm resistor must be between CAN high and CAN low. And don't forget that if you use CAN repeaters or bridges in your system to segment the bus or to use long drop lines. These segments, which are independent bus systems signal-wise, must also be terminated at both ends. If you need more information about the differences between CAN repeaters and CAN bridges, I made another video for you. And you can find the link in the description below. And now my third advice for you, keep the maximum CAN bus length in your mind. This is a really complex one. The signal on the bus is almost as fast as the speed of light. This is fast, but if you have to make sure that at a certain point of time the same signal must be present on the entire bus. This is required by CAN's arbitration mechanism. As a result, the system length is limited. The higher the baud rate, the shorter the maximum length of the bus system. Here's an example. Using a common configuration of the CAN controller, the length of the bus is limited to 110 meters when using a baud rate of 500 kbits per second. Devices with galvanically isolated bus interfaces add an additional signal delay which costs 30 meters. So if 110 meters is not enough, you have 2 choices. You can either lower the baud rate or you can use CAN gateways to divide the bus into several independent but coupled segments. I hope these tricks help you to understand more about CAN networks and, more importantly, how you can design in reliability. If you want more valuable information and tips, please subscribe to our channel. There are a lot of videos for you. And don't forget to like this video. And don't forget to download your white paper. The download link is attached below in the description of this video. See you very, very soon. Bye bye.